So I have here a fairly ancient model. I think it might even be older than the school, but it's a really good model of how an electric generator works. This is the basis for how we generate electricity. We're going to see that it's going to convert the mechanical energy I put into it into electric current, which is what all generators do. There's a few basic parts to it. There's obviously the crank. There's a magnet, and the reason there's a coil of wire around that magnet is it actually can be an electromagnet. That can make the magnet much stronger. Most important part, though, are these coils that can spin. And notice they spin between the poles of the magnet. We've talked about the idea of magnetic flux, and that's how much of the magnetic field is in the coils. And I think you could see when the coils are like this, the maximum amount of magnetic field can get through, because you can see the inside of the coil, kind of the donut hole. When it's like this, the minimum amount can get through, because that donut hole is facing away from the magnetic poles. So as I crank this, the flux will increase and decrease, and as we've seen, that generates an electric current. Current output from this model is not so big. We're going to measure it with the galvanometer, the same one that we used when we did our bar magnet and a coil of wire. Let's hook it up at first. And we can see that without the electromagnet turned on, not much happens. I crank it, needle moves a little, but we need a stronger magnet. So I'm going to disconnect the galvanometer to protect it. We're going to plug in the electromagnet. Got a fairly low DC voltage there. We'll hook the galvanometer back up, and we'll just start giving a crank. So I'm going to keep cranking always in the same direction. But watch the galvanometer. Something really interesting happens. It's alternating. It goes back, forth, back, forth. But I'm still cranking in the same direction. So what I'm making is an alternating current. And I want to talk about why that is. If we look at the flux, right now we're at maximum flux because the magnetic field is going through the donut hole. But as I spin it, now the donut hole is facing away. Now we're at minimum flux. Now we're back to maximum. And what's happening is it's shrinking to zero, growing to maximum, shrinking to zero, growing to maximum. And those alternate shrinking, growing, that's what actually produces the back and forth current. So what I'm going to do is I'm going to alter now the setup here, because I want to show you something interesting about this device that can make it a DC generator. If you look, right now I've got one of the pieces that the galvanometer is hooked up to on this piece of metal, so we call that a brush. It's brushing against the spinning part. The other brush is on this middle setup. And as I spin it, I think you can see that they're both solid pieces of metal. And all they are is one is hooked up to one end of the coil, one's hooked up to the other. But check out this last place. There's a break in the spinning part. So if I put the brushes there, something really special is going to happen. And I want to show you what that is. So I'm going to stop the video, I'm going to reset the brushes, and then we'll take a look.